Okay, so here's another example of a rational equation. It's very similar to the last one we did. So we can think about the excluded values. I'll do that right at the top here. You can do it at the end, but you just have to remember. So in this case, we can't have x be 0. X cannot be 0, so we just have to remember that. I'm going to rewrite the problem so I have a little more room. I'll show you how I do that. I leave a little space so I can do the distributing. Now, the LCD, in this case, I'm going to need a factor of 2, and I'm going to need a factor of x. And that's enough. So I'll multiply by 2x. And I'm doing the distributing right now. So, and I have to write it out twice that way. Every term gets the LCD. Now the whole reason to multiply by the LCD is to get those denominators to cancel. So that x is going to cancel with that x, and I'm going to get 4. 2 times 2 is 4. Minus, now there's the subtraction sign. The 2's cancel here, so I get 3x. And then on there's the equal sign. The 2 cancels and the x cancels. So I just have a 7 over here. Now that's a friendly equation. That's like a little linear equation that we've been working with, so that looks good. Okay, so now we're going to solve this by subtracting 4 from both sides. I get negative 3x equals 3. I'm going to divide both sides by negative 3. Remember, when you divide, it's by whatever that coefficient is. If it's negative, you divide by a negative. If it's positive, you divide by a positive. Okay, it looks like I'm getting x. Oh, I ran out of room. X equals negative 1. Now, is that the excluded value? No, the excluded value is 0, so we're okay. X equals negative 1. Okay, so I'm going to do another example. It looks pretty similar to this one. So we'll talk about the excluded value. X cannot be 0. Now, if you're thinking about that, what would make the denominator 0? Well, if it's just x, that would be 0, right? 10 is going to be 10, so you don't have to worry about that one. But when would 4x equal 0? If x were 0. So you're thinking about when would those denominators equal 0. Okay, I'm going to recopy this. I'm going to leave a little space. And I'm going to think about the LCD. Now, the LCD, what's the smallest number that 10 and 4 would both go into? 20? You might be saying 40x, but you could do that, but it's not necessary. That wouldn't be the LCD is the problem. So 20, and then I also have to have a factor of x. So everybody gets multiplied by 20x. Each term gets multiplied by 20x. Now, if you want to put 20x over 1, so you remember, oh, it's in the numerator, that's fine. Okay, then you're going to cancel. Here the x's cancel, and I get 20 times 1, which is 20. Over here, 10 goes into 22 times. Now, don't miss that little x there. So it's going to be 2x. And then over here, 4 goes into 25 times, and then the x's cancel. So I get minus 15. Okay, so that's a linear equation. So I'm going to add 15 to both sides. I get 35 equals 2x, divide by 2, and I get x equals 35 over 2. I would just leave it as an improper fraction, like that. We know it's not 0. 0 is the excluded value right up there, so I'm good. The answer can be x equals 35 over 2. Now, a couple things. First of all, 0 is not always the excluded value. It just happened to be in the 3 examples that we've done. Sometimes 0 is fine. Sometimes it's another number that's the excluded value. Okay, sometimes there's more than one excluded value. Okay, but so far we haven't run into that. And what happens if you do get x equals 0? Like you do all this work and you get x equals 0, and that's the excluded value? Well, then there's no solution. We'll hopefully have an example somewhere like that.